Coco. Peace for all. I have got some idea. You hopeless homeless freezing on the fucking street among fucking anything fucker, anything killer, zombies. I put all my soul and faith in Jesus. I give to him, and please save us all. Give soul for the motherfuckers, please, Lord. And anything fuckers. So, yeah. Ferrite core transformator of a television's CRT. Cathode radiant tube. Ferrite ring. Twice symmetrical. Hundreds of turns with a thin wire, maybe 0.3 millimeter diameter magnet wire, LAC cable. So it looks like I tried my best. Like this, outer diameter, inner diameter. There is the middle gap, the air gap or whatever. Should put an extra insulation, put extra isolation. I like more the C instead of T, isolation. So put extra isolation, like power tape. That's the best, I mean. So then there are the many hundreds of turns, twice on both sides, and now it will become interesting because first of all we make wait, that will be really interesting. We make the circuit, the driver circuit, but first of all we put aluminum around of the core, both one side, yeah, around of the more hundreds of turns, but we don't close it. We leave it open, and we use it as a one turn primary coil. Okay, after that we attach some copper cable, of course, to be able to connect this foil. Yeah, and wait for it. This is just one step, but it will be really interesting. So I try to draw it. I don't know. So this is the foil. Okay, that's why I make the video, because it's not easy to see after when the plan is finito, ready, then it's hard to have it to understand. So this is a foil, not a coil, but a foil coil, one turn, okay, and not closed. So it has about 5 millimeter or 7 millimeter distance between the closing sides, okay, between the endings there, 7mm distance, not that the high voltage sparks. So one ending of the plate coil and other ending, I try to symbolize it, so like that, the other ending, okay. So we take that as primary. So then we have this 13007, which is the best choice. Minus, of course we need some protection. 5V CILINDER diode, pull down resistor, no idea, 50 kilo ohm for example. Then we have this trick from R.G.L. We have here the input power, the self-resonance trick from R.G.L, laser hacker. This will be interesting. Let's say 5 to 30 volts. But I mean, maybe it can work also from 1 volt or a half volt, who knows, because this is only one turn but capacitively coupled, so it's a really good coupling pairing. So then we use one side of the high voltage, may a few megohm of resistor, no idea, 1 megohm, just for saving the stuff. And here also should put another CILINDER diode, and another resistor. We need some more place. I hope I do it good. So then 100 kilo ohm and 50 kilo ohm, for example. And of course this is also 5 volt CILINDER. I hope it can survive. If this is 100 key and this is 1 megohm and there is more thousands of volts, then we need here maybe 10 megohm. That's a question, but okay. We can use also 10 key and 1 megohm, so try it. And more pieces, from more pieces is better, but okay. And for here we have to limit this current, opening current for the 13007. It has beta HFE of about 20 to 30 maybe. So it's the amplifying factor. Okay, so let's say 1 kilo ohm. No idea. Set it. Wait, potentiometer. Just set it. And here a fixed one. Sure is sure. 100 ohm. Yeah, so as the high voltage gives us impulses and comes in sine wave resonance, it opens and closes, opens and closes, open, close, open, close, open, close. Okay, we don't need the galvanic connection between the emitter and the other side of the coil, because that is high frequency and high voltage. But what we can do, for example, take an earth ground. Yeah, or but wait, we have to tune first. What we need? Condenser. And what kind of condenser? That will be fun. Plate condenser. Plate. Aluminium foil. 30 times 30 centimeters. Okay. Alu. And in between, of course, some isolation tape, 3 layers. Tape, not tape. Okay, so and this plate, sorry, I should draw it like, okay, wait, because it has to make so placing like this, or making tubes, high and low tubes. So this is the ring, upper tube condenser for this side, and downer tube, bottom tube resonator for this side, you know, and from the middle to up and from the middle to down, so that all the radiation goes to the condenser. But I cannot draw it here, so how in the fuck can I show in 3 dimensions? It's impossible. Impossible. Not possible. How in the fuck do it? Fuck. No idea. I make another stuff here. Okay, so yeah, this is the condenser. Okay, fuck no. Okay, don't fuck it for hours long. But these condensers, it's so fooey. Cylinder condenser, okay. Inner and outer plates closed. Closed, that's very important. Cylinders, okay. And cylinder, high voltage, and in between comes the fucking isolation. Okay, okay, alu 1, 2 points of the condenser. That makes the condenser. Okay, fuck, sorry. And here inside is the ferrite of the CRT. Okay, something like this. Here is the cutted middle point, this, and more hundreds of turns. Yeah, and pom and pom, and from the other side coming too, from this side. Yeah, wait. Yeah, okay. So L1A, L1B, L2A, L2B, 2B, and so we connect to the condenser stuff parallel. For example, okay, this is the cylinder capacitor, C cylinder 1, other, wait, yeah, oh fuck, no, wrong, I made it wrong, because it goes to the L1A here. So that's some tune stuff, okay. And the other, so this is the very middle of the transformator. There's some place. The other condenser, cylinder, same size, like this. Sorry, it's too big. Okay. And there is, of course, the aluminium one-turn coil also, but oh, so we have the aluminium stuff, alu coil, one turn. This is the capacitor cylinder, 3 layers isolation, and so on. Yeah, I hope you can imagine it. So all the radiation of the core is coupling into the directly into the cylinder tunes capacitor cylinders. Okay, and by this one turn, zero inductance but capacitively coupled, so it's almost zero nanohenry, no idea, but this is capacitively coupled to all the hundreds of turns of the first side primary. Okay, then one more trick is you can ground it, for example, or you can, which side is, yeah, egal. But you have to ground it too, so it's a second ground if it is possible. Second ground, so ground 1, ground 2, and 10 meters distance. Okay. Two grounding stuff. Wait, because we have to put load. That's the important stuff, because there comes the extra energy. As I have seen in one video, almost the same load. In more videos, the same method. So if you have here a high voltage resonance system, and usually they use a plate here, an antenna plate, yeah, between the ground and the antenna plate there is the resonance, high frequency resonance. But we use here the condenser, the tune condenser capacitor as antenna plate, and all the energy is concentrated here on the transformer and in between the condenser cylinder and antenna plate. So it's a high reactive power going on, resonance power, and it's also scalar wave and earth pumping effect. So you bring here in high voltage resonance one cylinder, and then for the load, yeah, you have to connect this sheet to, it's not sheet, but to BE, to the cylinder capacitor you connect it, okay? And like that the parallel LC resonance. So you take the outer side, here comes the load. So now you can imagine it. This is the ground 2, okay? Be fucking careful, because there is really high voltage, a big amount of high voltage. Yeah, this is a S5, what? S990, S8550 or 8050. Yeah, that is called S8050. That can handle about minimum half an amp, so 500 milliamps on maybe 30-40 volts. Yeah, this is it. So these condensers, tuning condensers with the hundreds of turns, 1, 2, are the cylinder capacitors, okay? There is isolation from power tape, for example. So you can take this also as a capacitor plate and as primary coil too. So around the ferrite. So for example, if this is the ferrite, you can imagine it as a ferrite. It's not, of course, but yeah, then there is the cylinder capacitor, okay? Then that is the cylinder capacitor, and of course double layer, and in between comes the power tape, power tape, yeah, 3 layers, because we need 15 kilovolt isolation. Yeah. And on the condenser, if you wish, you can place an extra spark discharge tube. So if it goes high to, no idea, 3000 volts or 5000 volts, you can use parallel with the LC gas discharge tubes. Okay, yeah, sorry, like this, gas discharge tube, GDT. Mit, weiß ich nicht, don't know, 1000 volts, no fucking idea. So that brings an extra wide band spectrum noise into the system via spark gap. It's a spark gap closed in a tube, gas discharge tube, GDT. The spark gap causes a real brutal wide spectrum E-field, electrostatic field, and extra noise into the system. So all the parts of the system, cables, no idea, everything, the cylinder becomes this wide spectrum of resonance frequencies. So like that we are amplifying the reactive power. So whatever you put as load in between the high frequency, high voltage resonance by spark amplified resonance, and this side, and the ground too, that will become a real high power energy. Yeah, and I will put here a link of a video from a Russian engineer, a hobbyist engineer, free energy researcher. He was able to use two high voltage transformators. On one high voltage transformator he made resonance like a mini Tesla tower. He made a mini Tesla tower with ferrite rod. I will put here the video, that video. So mini Tesla tower with ferrite rod and an other high frequency, high voltage transformator to step down the power, and of course the other side was grounded. The very same method as here is shown. High voltage, high frequency resonator, load, and ground. Here he had more power output than as he put it into the system. He used a similar method, not that efficient like my idea, but yeah. And his driver was not Laser Zeber's circuit, but it's all about self-resonance. So it will set itself in a high efficient reactive resonance state. Peace. God bless you all.